Today's webinar about healthy indoor lighting. Some of you may know me because I work for our Nordic team, but those of you who don't know me, my name is Marit, and I will be the moderator for today's online event. As you see, I have here two of my colleagues, Rene and Sadaf, with me. But before I introduce you to them, I would like to briefly touch upon the topic that we're going to be having for today's webinar. So today we're going to be talking about light, but not just any type of light, but we're going to be talking about light that has a biological impact on us human beings. Because we know light is crucial for the life on our planet, not just for the plants and animals, but also for us human beings. Think about it. If we want to grow, if we want to feel good, we need to sleep, and we need to sleep well. And in order to sleep well, we need specific type of light throughout the day. And that is going to be the focus where Rene and Sadaf will be focusing today. So let me introduce you to them. We have Rene from our research department. He's our scientist, and he has done an extensive career in both studying and developing LEDs here at Signify. Then we have Sadaf. She's our product manager, and she's the expert when it comes to Philips indoor modules. And they will be your guides for the next 45 minutes. And they will guide you through these topics. So first, Rene is going to introduce you what actually is healthy indoor lighting, why is it important, and what are the key metrics for optimizing it. Then Sadaf will introduce what kind of options we have available for your fixtures so that also your customers can enjoy the benefits of healthy indoor lighting. After that, I'm going to be running through a short summary and then host a Q&A session. So already now, while they're presenting, if you have any questions, feel free to type them in the Q&A section. So you find it with the 3 dots and there's a Q&A tab. So please feel free to use that for any of your questions. But now, Rene, I think it's your time to shine. I will pass it over to you.
Thank you, Marit, for the nice introduction. So as Marit explained, I will further explain what healthy indoor lighting means and what are the key metrics to optimize. So as mentioned, light is very important for us. Light is a nutrition for our body to function well, because light tells our body if it is day or night, and that's very important for us. So light wakes us up in the morning. The morning light, the absence of light in the evening makes that we understand that we have to fall asleep. But also daytime light is very important to provide us later for a sound sleep, and also have a good mood and have a better functioning daytime. So that is the focus of the presentation of today. Next. Yes. So actually, if we look at the biology here, there are 2 pathways of what the light is doing via our eyes. Of course, we know the visual pathway. That is the function that gives us that we can see, our vision. But there's also a non-visual pathway which also goes via the eye, and that is the one that regulates our circadian rhythm. That tells us if it's day or night. The way it works is that light is falling on the eye, and there's a special photoreceptor in our eye, which is there to give a signal to the brain, to the central body clock, to give a signal if it is day or night. And therefore we call that a Zeitgeber for our central body clock. And what does it do, that light? Actually, it regulates the sleep hormone melatonin. Melatonin is a hormone that is produced in our body at night, and because of that, our body knows that it's time to go to sleep. And therefore, it is also important that during the day, this hormone is not produced, and that is being done by light. The light that is hitting our eye and is absorbed by the photoreceptor gives a signal, tells our body not to produce melatonin. So the production of melatonin is actually suppressed during the day, and it's crucial that light is falling on our eye for that. So yeah, that is what we call healthy indoor lighting. So light that is able to arrange this functioning, and it makes us make the circadian rhythm function well. And we also call that melanopic lighting. So if we do indoor lighting right, it can also function as a Zeitgeber for our circadian rhythm. But we really need to make sure that we do it right. And there are several factors that are there of importance. First of all is the timing. So we need to have light during the day and not in the night. And it's most important to have high intensity of light in the morning. Second is the intensity. So generally you can say indoor, the more light the better, because as I will show later, indoor light levels are really low from biological point of view. It's much lower than outdoor. So in general, you can say the more light, the better. And the third aspect is the spectrum of the light, because actually this photoreceptor in our eye has a certain sensitivity, and that's given by this graph over here. It actually absorbs blue and cyan light, and it peaks in the cyan. So therefore, you have the biggest effect of this non-visual pathway of this influencing the circadian rhythm with cyan light. So those are factors. Then we as researchers also find it important, and I think it is generally important to know how you then can quantify this effect. So you need to have some metrics that tell you if a light source is good or bad, let's say that way. And we have two metrics that we use. One is the melanopic daylight efficacy ratio, melanopic DER, and the other one is melanopic equivalent daylight illuminance, melanopic EDI. This melanopic DER, that is a parameter, a metric that is fully only related to the spectrum of the white light. It is actually relating the biological effectiveness of our light source to the biological effectiveness of a reference light source. And that reference is daylight D65, which is actually a spectrum like outdoor lighting. So it is a relative parameter. You divide the biological effectiveness of one source by the other, so it does not have a unit. And it depends on the spectrum only. It's really a spectral parameter. The second one is this melanopic EDI, and that is more the functional parameter. That is saying how much melanopic light is falling on the eye, and that is in the end what counts. So melanopic EDI is like regular illuminance as expressed in lux, but it is lux on the eye. So that is important to realize, and that we call a vertical illuminance, and it's called vertical because it's falling on a vertical plane. And it's different from how we normally specify our light designs, where we more look at horizontal illuminance on the desk. So that's important to realize. It's about the light falling on the eye. It's an illuminance expressed in lux, but it is weighted using the melanopic DER. So in a formula, the melanopic EDI on the eye is the vertical illuminance on the eye times the melanopic DER. And this is this is the functional parameter. This thing needs to have a certain value. And then the next question is then, how much should it be? And that's on the next slides. So how much melanopic EDI should fall on the eye to have healthy indoor lighting? Or to say, in slightly different words, what are the recommended melanopic EDI levels to prevent biological discomfort? Well, here is a picture that shows how bad actually our indoor lighting is for this circadian rhythm point of view. Because outdoor lighting, as you can see, biologically active light levels are in the 10,000s or 100,000 of lux, while indoor lighting, we're talking about 500 or 300 lux often. And we can easily say that we can call that biological darkness. For the circadian rhythm, these levels are really low. So these are lux levels on the desk. If you translate that to melanopic EDI, so you then look at the vertical luminance on the eye, and you take a standard indoor lighting condition like 4000 Kelvin, then we optimize in Europe for 500 lux on the desk. That translates to a melanopic EDI of about 125 lux. So then the question is that enough? Well, you probably already know the answer. No, that's not enough. What is enough? Well, then there is, of course, their research has been done. And actually, a few years ago, the most important scientists in the field of circadian rhythm came together for a workshop with the goal to define these recommended melanopic EDI levels for indoor lighting, for indoor conditions, at various times of the day. So in the night, in the evening, and in the night and during the day. And what they did is they actually collected a lot of data from experiments, from research experiments, which were done over decades. And they have put all these data together. And these data are tests where people have been exposed to certain light conditions with a certain melanopic EDI, and a certain response was measured. For example, the melatonin level in the blood. But there were different types of responses, and therefore you see different colors here for the data points. But if you put all these data points together, and that's what they did in this workshop, you see that you get this S-curve. And this S-curve is that gives the response of the human body to certain melanopic EDI levels. And from this, it was defined what is then the recommended level for daytime indoors. That is this level over here. And that is 250 lux, a melanopic EDI of 250 lux. So that is 2 times more than what we normally, on average, do in Europe indoors. Okay, 2 times more. That's one way to look at it. There's another way. There's also another way that such a recommended level has been defined, and that has been done, for example, by the Wegh organization. So health and well-being building certifications are evolving, and Wegh is one example of it. What Wegh is doing, the Wegh Building Standard, is a healthy building certification program by the International Well Building Institute. And the aim is to enhance the human health and well-being, the health and well-being of the people indoor in the buildings, through optimizing the design and the operations. And it offers for the persons in the building, of course, it's good for their health and well-being, but it also offers an opportunity for the building owner to increase the value of the real estate. And requirements are given in various categories, not only lighting, as you can see over here, but lighting is one of them. And within lighting, circadian lighting is one of them. And so if you have such a certificate, then you have a number of benefits. So, and then if we look at what Wegh defines, Wegh has defined for this, it is a point system. So you can earn points, and the more points you have, the better certificate you get, or you need a certain amount of points for a certain certificate. And they have defined 2 situations. One is there is no daylight at all in the space. The other one is there is sufficient daylight falling into the room via windows. In the absence of daylight, and if you want to reach 3 points for the circadian light, then you need your artificial light needs to provide a melanopic EDI of at least 250 lux. Not surprisingly, the same number is on what the researchers came up with. If there is sufficient daylight falling into the room, so there is already light coming from outside, then for 3 points, your artificial light needs to generate a melanopic EDI of 163 lux. And if this Wegh Building Institute has defined actually this melanopic EDI levels, which we use, but they've also defined EML, equivalent melanopic lux levels, which is a different parameter. If you're not so familiar with melanopic EDI, but more familiar with EML, it's actually a very simple conversion factor. Okay, so now we know the levels that are recommended. Now how we're going to reach those. So for that, we go to what we as Signify have been doing. So we have chosen the direction to enhance melanopic lighting also by spectral engineering. Because if you would not, you would simply have to say double your light amount that you have to generate, which will cost you a lot of energy, at least twice as much. And it will start probably also to be very glary if you have 2 times more light out of your luminaires. And it will also generate a lot of heat, so it's not ideal. By spectral engineering, you can do that better. And that is why we chose that direction. Because actually, what turns out is that the LED sources that we normally use over the past decades are not very good for this from this biological perspective. because we have optimized fully on vision and on efficiency. And for LED, that resulted in this spectrum, which is this white spectrum here. This is a standard spectrum for 4000 Kelvin CRI 80. And what you see is that there's a dip in the cyan. So not very good for stimulating our circadian rhythm during the day. And what we do is we have changed this spectrum and applied a cyan boost, as you can see in this spectrum. So this white spectrum is also 4000 Kelvin CRI 80, but now with a cyan boost. That's what we do in BioUp. And the way we do it is we have developed special LEDs for that. And we have two versions. One is this one, where you have an LED which emits cyan light. So the semiconductor chip in this LED emits cyan light, and there's no phosphor in this package. So this package only emits cyan. And if you combine it with white LEDs, the right white LEDs in the right ratio, then you can reach 4000 Kelvin CRI 80, but then with a cyan boost. The other way we have also done it is by taking this cyan emitting chip and putting it in a package, but add phosphor. And in this way, we make it a white LED. So this is and it's mainly red phosphor that you need to add. You get a white LED, and also here, if you combine it in the right way with the right other white LED, you get the right total spectrum, giving you 4000 Kelvin CRI 80 or something else. So that is how we ensure to do it. We have developed special LEDs for that. And then a little bit more details about those sources. So we have actually two types of sources in BioUp technology. We have CES, cyan enhanced static, and CED, cyan enhanced dynamic. Let me first explain static a little bit more. So the benefit of this CES BioUp solution is that it gives you melanopic stimulation close to that of the spectrum of daylight, but then at a neutral CCT. So not at 6500, which we indoors find generally too cold, but at a neutral white CCT, which we find acceptable indoors or even pleasant. And it's the easiest and most energy efficient way to reach this melanopic EDI of 163 that you need if you have daylight. And the way you, and by the way, there's an additional well point that you get because R9 is above 50. And why is it so easy? Because it is just a drop-in replacement for currently used fixed white light sources. If you have a luminaire with a current standard level 2, you only have to replace it by this one, and you have this pretty big gain in melanopic EDI, and you don't need to do anything else. You don't need to change the output power, so you don't have glare issues, and also you don't have controls because it's a fixed solution. So it's the most simple way. CRI is above 80, R9 is above 50, and the melanopic DER, the number is 0.87. And if you compare that with standard office standard 4000 Kelvin, it's normally 0.66, and D65, the outdoor reference, is 1. So you see that we really make a very big step and come close to the stimulation of outdoor light. And by the way, we do that then, here you see a picture of a board. We do that by the combination of this cyan LED with white LED, in this case in a ratio 1:4. For CED, there the benefit is this is the solution which gives you the highest melanopic stimulation, even higher, which you would need if you need to have 3 well points where you don't have daylight, because then you need to go to this 250 lux. So then you need to really do something extra. And also, so this melanopic stimulation is really equal to the daylight, but then at a still reasonable CCT, 5000 Kelvin. And the other benefit is you can switch it off if you want in the evening, because this is a tunable white solution. In the warm white channel at 2700 Kelvin, the melanopic stimulation is off. It's very, very low. Also here, an additional well point because R9 is above 50, and also an additional well point because of controllability. So here, this is a drop-in replacement for current tunable white light sources, then giving you this benefit for melanopic stimulation. The key performance specifications are here again, CRI is above 80, in the range up to 5000 Kelvin. Let me mention that you could go to cooler white, like for example, 6,500 Kelvin, but then the CRI goes below 80. That's why it is specified currently till 5,000 Kelvin. And the R9 is above 50 over this entire range, and the melanopic DER is 0.97 at 5,000 Kelvin, so it's really close to 1. And we do this by combining here these LEDs in the cool white channel. So here we use the LED with phosphor on the chip so that we get a white LED, combine it with other cool white LEDs in the proper ratio. And the benefit here is that we're only using white LEDs. So for color uniformity, this has a benefit. And actually for the CES solution, we are also working on making such a solution with only white LEDs for the future, and also then improving the efficiency. So that is about the light sources that we have, and Sadaf will later go in more detail into the products. But what I still want to do is I want to discuss a little bit if there's more optimization possible. So in research, we have looked into that. We have actually looked what is theoretically possible. And we did that by building spectra ourselves, by taking Gaussian emitters, as we call it. So there's like bands with a certain width, and we took 4 emitters and we combined them in all different ways to make a wide spectrum, just theoretically. That means different widths, bandwidths, and different positions. We made all these combinations, and for all these combinations, we looked at what is then the CCT, the CRI, and the melanopic DER. And here, what we've plotted in this graph is the maximum melanopic DER that you can get from theoretical point of view. What you see is that the melanopic DER increases when you go to higher color temperature. That is because the higher you go, the more blue is in the spectrum, so also more cyan. So therefore, you can reach a higher melanopic DER by going to higher color temperature. What you also see is that it depends on CRI. So you see in red that the maximum melanopic DER for CRI 70 is higher than for 80, and the maximum for 80 is higher than for 90. And this is a fundamental trade-off. If you want to go for the highest melanopic DER, then you give in on CRI. It's like always the way it is. So it's a fundamental trade-off. So these are theoretical maxima. What we then did is we plotted commercial sources. We have a database of many commercial sources, not only from us, but spectra from also from others, that we have data points for these spectra, and we plotted it here in the graph. And if you look at, for example, the black data points, the black is for CRI above 80. You have open data points and filled. The open ones are the regular sources, not optimized for biological effectiveness. And you see how much lower these are compared to the maximum. And that is also not a real surprise. As I mentioned, it is not optimized. And for normal sources, there is like a gap in the cyan. But then there are also optimized sources in the filled, the black filled symbols. And those are from so optimized for biological effectiveness. We have done that in BioUp, and those are the yellow dots. But there are others on the market with these kind of solutions as well. And therefore, there are more points over here in black. And you see that these data points are still significantly below the theoretical maximum. So you would expect a higher melanopic DER is at least possible. But the question then is, does it make sense? And yeah, I'm going to explain you in this slide that it doesn't make that much sense, we think. And that is because you shouldn't look only at the melanopic DER, but you should also look at the what we call melanopic energy efficiency. And the reason is that melanopic DER is a metric, a parameter, that tells you how much melanopic light is produced per lumen of light. But it does not say anything about how energy efficient you are producing that lumen. And we know how important that also is. Energy efficiency is obviously also very important. So we also need to look at how efficient are you producing that lumen. And we have the luminous efficacy for that. You all know luminous efficacy of a luminaire of a source. We also have a luminous efficacy here, but I'm using the luminous efficacy of radiation. That is the metric that says how much lumen do I get per watt of radiation. That's our pretty high numbers, as you can see here in this graph, because I plot here melanopic DER versus luminous efficacy of radiation. You might think, what are these numbers so high? Well, that is because this is just part of the total efficacy of a source. Only the efficacy of the spectrum. And you have to multiply that with, for example, optical efficiency, driver efficiency, and then the total electrical efficiency of a source will go lower. But here, for the sake of completeness or simplicity, I only use this luminous efficacy of radiation. So what I did here is I plot melanopic DER versus LER and look at the maximum, the theoretical maximum again, for Sierra 80 at 4000 Kelvin. And you get this curve. So it shows that you can reach the highest melanopic DER, but then at the lowest LER, so at the lowest electrical efficiency. And that is a pretty low electrical efficiency. So the question really is, do you want to optimize for that? Because you lose electrical efficiency. And to have a better look at that and to know better where to optimize on, we as Signify propose to use another metric, and we call that the melanopic efficiency of radiation. It's the product of melanopic DER and LER. And we think you should maximize that because that is the measure for how much melanopic light do I get per watt. And here we've plotted that on the y-axis, again, versus the LER. And this is the same data as here, but now it's a different metric. And you see that you get a maximum. So we think you should optimize for that maximum because then you generate most melanopic light per watt. And here again, we can of course plot the commercial sources. That's what we did here, but now only the commercial sources optimized for biological effectiveness. The yellow ones again are ours. This is only CES because this is 4000 Kelvin. So at CES we have an melanopic DER of 0.87. And you see in orange other melanopic sources, so to say, from other vendors. You see already here our melanopic DER is pretty high, but you see if you look at the melanopic efficiency, energy efficiency, it is also very high. It is pretty close to the maximum. It's still there's still some to gain, but not that much. But also importantly, it's much higher than other melanopic sources on the market. And if you then look at that number, so this is really much higher. This energy efficiency, melanopic energy efficiency is much higher than the reference, which is this point over here, like 220 is it. And if you go to CED, then you even have an even higher melanopic energy efficiency of 280. So if you compare 280 with 220, it means it's 25% higher. That means that if you use BioUp CED at 5000 Kelvin, you need 25% less energy to generate the same melanopic effect, the same melanopic amount of light relative to standard 840. So it is a very, very significant difference, I think. And with that, I hand over to Sadaf.
Thank you so much, Rene, for sharing your in-depth knowledge on this amazing technology. With that, now I will be talking about the products in which this amazing technology is integrated. So as Rene mentioned, that BioUp technology or melanopic lighting is very important for the human well-being. It enables us to perform well, see well, and feel well. And thus, it is important to have that technology in our various platforms and form factor as well. So starting off with, I will be giving you a brief overview about our linear systems. Then I'll be talking about our smaller modules or the chip on board. And then we will be talking about the larger modules or the square modules in which this amazing technology is integrated. So first talking about our flagship brand in its particular technology, PhotoMOLED Strip Generation 5 Cyan Enhanced Dynamic. Now, I know that there are various players in the market that offer this technology. However, rest assured, Signify provides the highest melanopic DER possible with highest possible efficiency while maintaining the same light output. You must be aware of the tunable technology and you must be using it as well. And similarly, in the CED platforms, we allow color tunability between 2700 Kelvin and 5000 Kelvin. And the emitter that we provide with this module at 5000 Kelvin is 0.95, which is the highest in the market. We also maintain a very high efficacy with this module of 145 lumen per watt, while maintaining R9 of more than 50, which enables customers to gain additional well points as highlighted by Rene in his previous slides. Currently, this module is available in mid-flux or let's say 1100 lumen per foot, and it is available in both self and non-self versions. Like our Photomo LED strips, it is available in 20 millimeter width. That means that it is a drop-in replacement. If you're already using the Photomo LED strip platform, it is very easy to upgrade your indoor lighting to healthy indoor lighting and additionally gain some extra well points while providing the benefits of the biological lighting. Moreover, these modules, they offer a high lifetime of 70,000 hours, and we offer a 5-year warranty system with FlexTune drivers. These modules, as our Photomo LED Strip Generation 6 system, are used in linear backlit application, and as we see fit, they can be used in offices, hospitality, schools. But the applications of these modules are not limited, and they can be used in various other applications as well. Now, as Rene mentioned in his previous slide, we also have a simplified version of these LEDs, which are then integrated in our Photomo LED Strip Generation 5. So they are Enhanced Static or CES. These modules are available only in one color point, 4200 Kelvin, and at this CCT, the emitter of these modules is 0.86. While delivering a high emitter, these modules also provide a very high efficacy of 161 lumen per watt while maintaining the same light quality. This module, like the CED modules, is available in mid-flux, 1100 lumens per foot, and is available in two lengths, 1 foot and 2 foot, and both in LV and HV versions. The warranty and the lifetime are we try to maintain the same standards across all our modules. And we offer 70,000 hours of lifetime with a 5-year warranty system. Next, I will be talking about Photomo EdgeLit HV5. This is a fairly new product, so not many of you may know about it, but these modules are used in edge or side-lit pictures that use a light guide. Like the other modules, we try to maintain a high emitter on this module as well, while delivering high efficacy of 130 lumen per watt. This module is only available in 2 foot, and it offers lumen output of 3100 lumen at 2700 Kelvin. The key feature of this module is that it can be used in thin luminaires because it has a small width of 12.5 millimeter, and we offer the same high standards of lifetime and warranty on this one as well. Now, next, I would like to talk about our reflector systems. This is a fairly new family. It was launched a couple of years ago, and this has a wide array of technologies like CRI 80, CRI 90, and around 32 different SKUs, including a wide array of CCTs in this family. Also, we have Cyan Enhanced Dynamic, our flagship module and flagship technology in this family as well. And like tunable CCTs, tunable modules, it can be tuned from 2700 Kelvin to 5000 Kelvin. And if you're already using the tunable white versions of these strips, you can easily replace them with the CED strips, allowing you to gain additional well points and bringing healthy indoor lighting. We also maintain the same amount of high emitter on this module of the emitter being 0.95 at 5000 Kelvin, while delivering high efficacy of 135 lumen per watt. The key thing about this module is that we have developed it in conjunction with BJB, and it has a one-click fixation system. So all you need to make this module is the profile, the LED which is provided by Signify, and the louver and the optic, which can be ordered either from BJB directly or from Signify as well. These modules are available in 1 foot and 2 foot, and like the previous modules that I've mentioned, in low voltage and high voltage. And the warranty remains the same on this one as well. One key thing I would like to mention here that this is used for small profile luminaires which require a low UGR. Now, I'll be talking about the chip on board modules, and I'm not sure if you guys are aware, but we have this amazing mind-blowing technology on our smaller chip on board modules as well. And here we deliver an even higher EMDR of 0.97 at 5000 Kelvin CCT. This module comes in a square form factors, and it delivers high efficacy of 109 lumen per watt and 113 lumen per watt, depending on what size you decide to go for. And respectively, it delivers high lumen output of 1345 lumen and 2800 lumen respectively. We also provide compatible holders with it, and thus we provide much convenience to the customers as it offers a one-stop solution for customers to buy the holders as well as the modules. These modules can be used for spotlight, downlight, and decorative lighting, and they look very pretty in luminaires. The application for this, of course, not limited to the ones that are listed, but the way we see it, it can be used in commercial applications, hospitality, and residential as well. Now, from talking about really small modules, we start talking about the really big modules, or as we call 40 MOLED Square Generation 3. These modules, they like LED are, they also come in wide array of different CCTs and different technologies. But it also comes with our flagship technology of BioUp or melanopic lighting. We maintain a high level of EMDR on this one as well. And we offer high efficacy of 166 lumen per watt on these modules. These boards, they come in two different sizes and two lumen packages, 1250 lumen and 2500 lumen. And the dimensions of the square version is 260 by 248 millimeters. And the larger versions, or double square as we call it, is 520 by 260 millimeter. Like the previous modules, we also maintain high lifetime on these modules of 70,000 hours. And we offer a 5-year warranty system when paired with FlexTune drivers. These modules are used in area backlit illumination and mostly used in offices, schools, and hospitals. With that, I come to the end to my part of the presentation. I hope I have informed you sufficiently about the different platforms in which this amazing BioUp technology is integrated. And if you have any further information, please feel free to contact myself or your key account manager. We will be happy to tell you more about these products and even share samples with you if required. Now with that, I hand over the floor to Marit.
Thank you so much. So wow, that was a lot of information the past 40 minutes. Let's go through a short summary. What is it that we just learned from Rene and Sadaf? So first from Rene, we learned that light is the most powerful regulator for our internal clock. So telling for our brain whether it's day or night and whether we should be sleepy or be alert. And therefore all these variables that have an impact on the biological effect of light should be taken into account when planning indoor lighting. And if you do it right and you optimize the amount of melanopic light per watt, you can make energy savings up to 25% while still maintaining the same melanopic impact for the people working or studying under your luminaire. From Sadaf, we learned that BioUp is not just a product, but it's a technology embedded in our Philips LED modules, and they are available for your fixtures, so people working or studying under different fixtures can enjoy the benefits of healthy indoor lighting.